Okay, so let's continue. We'll take some examples of some logical queries. Now these are going to be a little bit artificial, but bear with me, we need to illustrate a point. We have some geographic data here and the table associated with it. So we have some residential buildings here, houses, and then we have some industrial commercial locations up here, a sort of industrial estate, if you like, owned by different people or companies, and occupied by various people, companies. Not always the same. So each row of this is equivalent to one building, one object here, excluding the roads. And the use tells us which type of building it is. And then we have two other attributes. We have the owner and the occupant. So let's do some basic queries here. So if we want to find out those buildings where the use is equal to residential and the owner is this B. Jones person. So we have two rows here where the use is residential and the owner is B. Jones. Now, coincidentally, we have B. Jones as the occupant in one of them, and we have this other C. Svensson as the occupant in the other. So two properties have been marked out, two residential properties, both owned by B. Jones. Which is which of these, where B. Jones actually lives, isn't clear. We just have those two marked out because we took these two qualities where both that and that are fulfilled. And then we have two cases of that. It's both residential and owned by B. Jones. Residential and owned by B. Jones. So that's our query there. Thank you, Del. We can have a different query. We can use the or now, where the occupant is B. Jones or the owner is B. Jones. We've dropped the requirement for the use being residential, and we are looking for the owner here. Well, there's the owner is B. Jones there, B. Jones there, not there, not there, not there. There we have the owner B. Jones. And the occupant as well. Well, if you look at the occupant, there's B. Jones there, not there. No, don't say so. Only that one. But then, coincidentally, it just happens that B. Jones is also the owner there. But that was actually not terribly relevant to our query. We were just interested in the or. Either one fulfilled doesn't matter, and that ends up with three properties. We also now get in this commercial property here, because we were not interested in whether it's residential or not. We were just looking for the owner being B. Jones or the occupant. If we then do the exclusive or, where the occupant is B. Jones or the owner is B. Jones, but not both at the same time. So this, for example, if we were looking for, so let's say our landlord is this B. Jones person, and perhaps we don't like them. We suspect them of being somewhat unfair in their rental practices. Obviously, we don't care about where they live because they can overcharge themselves in terms of rent. That's up to them. But are they behaving well towards their guests? So where do they have property that they are not actually using themselves? So that would be one particular use in this rather strange example of how we could use the XOR function there, because we don't want our B. Jones person in both columns here. We want them to be just one or the other. So that's an example of that. Now let's look at combining and negation. So we can actually use equals residential. So we look for residential here. All of these are residential. So far in this first part of the query, use is residential, we should get all of those. But there's a second condition, and let's ignore the not for now, and the owner is equal to the occupant. Where do we have owner equal to occupant? Well, we have that one there, we have that one there, we have that one there, that one there. You can see here that the two that have been missed out are where the ones that are actually marked. and that was this not function. So first of all, we looked for where we do have the owner equal to the occupant. And in all of these, A. Smith, B. Jones, D. Patel, E. Schmidt, F. Peters, and I. Silva, the owner is the occupant. They own their own properties. But then we negated that. We used the not function and switched it all around, which then tells us where do we have people renting from somebody else, potentially. So we want residential houses, residential locations, residential buildings where somebody is renting the property. And that's what we got from this query. Now, was that the most efficient way of doing it? Perhaps not. But it is one way of doing it, and that's certainly what the results of that query would be. So let's look at SQL queries more specifically. The SQL query, the type that we are mostly interested in from a GIS point of view, looks something like this. We actually don't need all of this really for GIS, but let's just start by looking at the basic formulation for SQL, what's actually happening. This first row, select column name from table name. What does that mean? Well, if we exemplify all of this, select city name from towns 1. Select column name, this is city name here, this is our column name from towns 1. This is the table. So this is saying go to this table and select that information. Now, this is the standard way of putting the SQL query. You may think, and I certainly think, it's a little odd. I would rather write from towns 1 select city name. That tells us to go to that table, then find that column, rather than look for this column in that table. This is the way it's written. That's just how it is. So let's accept it. So this first row here says city name from towns 1. What does that get us? That gets us all of the city names. A Town, B Berg, Seaport, D Dunman, E Village. So all of that, and it just returns the names. It returns that column. It doesn't tell us anything else. All we're going to get is from that table which towns are listed, which city names are there. If we go to our next column, the star, this is a standard indicator of everything. There's a star. You may recognize the asterisk star function there as basically a sort of joker, as it were. Anything, I'll match up with anything. I don't care. So this is saying every single column in this table, I want all the data. Just get me every single column of information. And that is actually standard in GIS. That's what's happening most of the time when we do our queries. We will be returned the entire row of data or table of data that we want, rather than a specific column, a specific attribute. If we look at this now, where we put in a condition, so before we didn't have this where part, select, and now we're going to select the city name from the particular table where, so now we have a condition where the population, that's there, is greater than 10,000. So we're returning the names of the towns where the population is greater than 10,000. So we're looking in this column first and saying, where do I see population greater than 10,000? See it there, there, and there. Okay, what information should I send back? The equivalent information here under the city name. So these 3 names are returned. We can expand that where we do the same search. It's the same condition, 10,000, and an additional condition where the ID has to be less than 4, for whatever reason. And here we can see that both of these two, the ID number is less than 4, so we end up with these 2 towns, Biberg and Seaport, fulfilling both of these queries. And we've returned just the city name. If we then go to the next row, where the population is greater than 10,000, that's these 3, or the ID is less than 4. So this row here doesn't come in because of the population. Its population is too small, so it doesn't fulfill this query, this condition, but it does fulfill this condition. So it gets included. So we get these 4 coming back. And then we go to the last row, and we want the city names of those towns where the population is not greater than 10,000. So population, look for population greater than 10,000. That's these 3, and then invert that. Now, of course, that's not a particularly efficient way of doing things. We could have just said where population less than or equal to 10,000, but we didn't. We did this instead, and then just inverted everything. We end up with the same result, similar result. Be a little bit careful when it comes to the greater than, because we have greater than or equal to. So there is one, if we were to have a 10,000 population in there, we would need to actually specify greater than or equal to in order to include it. Otherwise it would get missed out on greater than or less than. It would exist in between the two. But this is the not function inverting that condition. Let's test that. So we'll go through this slowly and see what we can if we can work out what's going to happen now. Another example, we'll run through the table again with new queries and see if you can work out what's going to happen now. So if we look at this first example, select population from towns 1, we know what that means. We're going to get the population data from the table. So the population column is here. We're going to get population from this table, and the conditions are here, where city name equals a town. That wasn't terribly difficult. City name a town, 1,000. Next row, population from towns 1. Yep, got that. This is all the same. Where the city name equals a town or Bberg. So the city name, which is this column here, equals a town or Bberg. So what happens now? We get an error. We get an error because the grammar of this is not correct, as it were. We've been imprecise. SQL is very demanding of precision, and there are good reasons for this. If we think back to our previous examples, the or, we could look for something completely different. Then we could have city name equals a town or ID equals 2. They didn't have to be the same thing that we were investigating, the same attribute that we were looking for. And so it really requires us to look for the specific attribute. It says, which attribute are you looking for? I am looking for city name, the or here. So it's city name equals a town or city name equals Bberg, not or Bberg. So this, we could simplify this in a slightly more advanced SQL query where we don't need to specify that again. If we we create something called a list of values that can be fulfilled or can fulfill our query within this attribute. We'll skip that for now. We can look at that another time. But the basic grammar that we need to look at here is that we specify for the or which attribute it is we're looking at, and does it fulfill this condition. So if we go on to the next row, and this looks good, doesn't it? We have city name equals a town, and we've been very good. We've specified which attribute we're going to be looking for. And what do we get back now? Well, now we get back nothing. In a lot of versions of SQL, we will get back nothing. There won't be an error. It will just return nothing. It'll look like a perfectly valid query to the computer, and it is in many respects grammatically correct. It's impossible. We can see that it's impossible for this to be both things at once. That we know, but it's correct. It does what it's looking for this. It doesn't have a problem. It knows where to look and it knows what to look for. It's happy, and none of these are both a town and Bberg. They're two separate entities, and it just says, "Yep, I've done the search. All look good. Nothing to return." This is particularly dangerous This one you really should look out for. This error, it throws up an error. It says, oh, this isn't working. This is not good. This, you can, if you're not careful, you can end up with something that runs fine. No complaints, but it doesn't give you what you think it's giving you. And this normally happens when you mix up or and. You forget which one does what. And what you wanted actually was or, and you put in and. You searching through the data, and you're getting something returned, but it's not what you think it is. Whereas and we can use when we're looking at, say, two different columns. There is a potential use for and to be looking at the same attribute twice in different ways, but let's not worry about that for now. Let's keep things simple. So and when we go then and look at a different column, and in this case, it's looking at the same. It's coming up with the same answer twice, where the city name is A Town and the ID is 1. Yeah, it's still returning the 1 value, and it returns it once. It doesn't return it twice, in case you were wondering. So it's only the same object is returned the once. And if anybody's wondering, just to look at the grammar of this, or how these are written, each of these finishes with a semicolon. Again, you won't have to worry about this when working with GIS. The semicolon at the end is there for the language, the SQL language, to say this is the end of the statement. Not all variants of SQL require it either, but when you're working with GIS, you don't even need to think about that. That's done for you, so don't worry about it. So that was, again, returning to this thing with GIS. The SQL's queries, we will use them to find objects within our database, in our maps. But this part here, if you remember that the star said get everything from the table, all the attributes that are there. That's the standard implementation. Select everything from this table, where the table is actually the active layer, the layer you've specified. You say, I want to search in this one. It writes this bit of the query for you, all the way up to and including where, and then you have to give the conditions. You have to say where something is true or not true. So that's how SQL works. This is select by attribute in our GIS. The other way we can select data in GIS is graphically or spatially, as it were, in the map. So we can just draw a ring around or a box around some data. Give me those. I want those. We don't know what their attributes are. We may not even know what attributes it may possess. We just know that they're in the right place. I want those things. So that is actually that is almost the defining feature, as it were, of GIS. The fact that we can do this and mark out things spatially without knowing anything more about them. We just know where they are and grab hold of them. That is our a very fundamental function in GIS, as opposed to just databases. So the spatial selection.